Buddy Pond. What is good, my good buddies? Today is day 32 of posting each day. Today, I'm going to explain how I built a browser-based operating system in less than 1 megabyte of JavaScript. We're going to go through the architecture of Buddy Pond. This is the Buddy Pond. Welcome. Like I said, this is day 32 of posting each day until we fundraise $1 million for the Buddy Pond. Let's hop into it. So Buddy Pond is completely custom written, handwritten. There's no framework. We're not using any Svelte or React or anything like that for some very good reasons. Now let me explain how this works. So Buddy Pond consists of 117 separate applications. These are the applications right here. Each of these is a standalone unit that can be loaded, initialized, opened, operated independently of each other. I'll explain how they can communicate with each other in a moment and how they're linked. This is achieved through the central bp.js file. This is buddypond.js, right? So this is about a 400 or 500 line wrapper that is kind of the kernel of the system. The kernel or bp.js is responsible for loading, for opening, for injecting the script assets. So the way this works for each 117 apps is that the app can be independently loaded into the system on demand dynamically. So when we load the Buddy Pond homepage, this whole homepage can load in less than 1 megabyte of code, including assets and all the images. It's less than 1 megabyte. We could even further optimize that. It's not necessary. This is achieved through the very small core bp.js file, and then each of the 117 apps looks something like this. If you look at the code on my screen, we have the Hello World app. On the left here, you can see all 117 apps. Each app exports a class name, basic constructor. It's assumed that the bp.js file is passed inside the constructor itself during its initialization. Each app exports at least an init function and an open function. Init is called when the app is initially loaded into memory, and open is called when it's explicitly called to be open. You can see here in the init that we can load an HTML fragment. If we go to the folder here, you can see that we just have a little fragment of HTML. We have a little fragment to represent the CSS. Usually we namespace it by the app so there's no collisions. Very simple, very straightforward stuff. So if we called bp.open, like if we go to the SDK here, we can see some of the syntax. bp.load, right? bp.open. So if we did, open piano, I think if we click up here, we can open the piano. Let's find him. Right, so bp.open piano, and then it just opens up the piano app, yeah? And then we close it, and then it's gone. So this is how we manage 117 apps without taking up a ton of resources. The apps only load into memory when you request them, and then when you close it, it deinitializes and removes everything from memory. This allows the front end of Buddy Pond to scale. We could have 1,000 apps. We could have 10,000 apps, no issues at all. If we look at the Hello World, we have the initialization. We have bp.load, right? If we go back here, bp.load is a generic loading function. It can load JavaScript files, it can load ESM imports, it can load HTML fragments, it can load CSS, it can load data such as JSON. So here we load the HTML fragment, we load the CSS, and then when it opens, we call bp.window. Window is going to take in a configuration option to define the window. Window is going to be, one of these things here. If we open up the fluid simulation, we have a window here, right? So there's a generic windowing system, all custom written, all in JavaScript, all for the browser. So all of the apps kind of resemble this kind of structure. So the front end of Buddy Pond consists currently of 117 independent applications. Let's talk about the back end for a minute. Buddy Pond is hosted entirely on the edge of the cloud edge serverless, using Cloudflare, durable objects, Cloudflare workers, D1 serverless SQL, all of that. So if we go back to BP, currently there's 23 independent Buddy Pond backend services. So each of these services operate independent of each other. So, God forbid any of the services go down, the application's still going to work. I'll back it up a moment. If all of the services are down, the Buddy Pond desktop will still load. Yes, it can load completely offline. It won't matter until you actually connect and authenticate that it's going to communicate with these services. Each service is a separate Cloudflare endpoint. using durable objects. Most of them have WebSocket support, which is hibernating WebSocket. So the WebSocket can hibernate. We only pay for the compute duration as it's being used. For the long-lasting connections, it can hibernate, so it's not eating any electricity on the server end. And then as soon as you receive data or send data, it can resume. We got a little bit of a light problem here. That's okay. We're going to keep going. So if we look at some of the code for the back end, for example, I'm working on the inventory system. So the front end, all custom JavaScript. The back end, all Cloudflare workers. Each of the 23 services has its own unit test suite. This is the inventory test that I'm running right now, 122 tests. So all 23 services have a similar structure for unit tests and integration tests to ensure that the back-end services always work. Let's talk about how the back-end and the front-end communicate with each other. Yes? So if we go, let's say here, we're looking at one of the WebSocket connections for when buddies come in, right? For when a remote profile comes in. Here we have when messages or is typing. So the way that this works is that each of the apps has access to the BuddyPond event emitter, which is a namespaced event emitter that allows you to give namespaced events that can be listened to. So the front end is reactive to any of the data coming in. If you choose to, you can execute a callback for some of the back-end calls and do it inline. For most of the BuddyPond, what happens is that each of those independent services are communicating, not knowing anything about each other. When the data comes in, we do a bp.emit, like is typing or BuddyPond messages, and then any of the apps can subscribe to that. So like, for example, if you see we have the little reward timer here, right? Or the update coin balance. So anytime coins come into the system from any of the 117 apps, it's going to update this value here because this menu bar is listening for the reward event, or rather for the coin balance event. And any of the apps can emit to coin balance. There's so much to go over. There's so much that I could talk about for the architecture. I wanted to make a brief video to explain how this works. Allow me to recap. The BuddyPond front end, entirely custom written in JavaScript, all vanilla JavaScript. It has the centralized bp.js file, which is the kernel of the system. Each of the 117 apps are independent units that can be dynamically injected into the app on demand. They can be deinitialized and removed from memory on demand, so we can scale up to thousands and thousands of apps. The backend is distributed, scalable, entirely hosted on the Cloud Edge network. That means that when you connect to a BuddyPond backend service, it's going to be localized to the region closest to you. And the code is running right on the edge, so it's going to be very responsive, very low latency, very high availability. Each of the BuddyPond backend services is independent of each other. We have 23 services as it is. And when the BuddyPond backend, I'm getting excited. When the BuddyPond backend communicates with the front end, we're emitting namespace messages. So the front end is completely reactive to the backend data. It's very cool stuff. The build system is a custom roll-up script, right? So if we go, this is important. If we go back to the hello world, we can see it's just loading this file, and it's just a regular JS file here. So when you run the build system, each one of these apps is going to just have a min file generated along with the map, and then the bp.js loader is going to be intelligent enough to understand if it's running in production mode or dev mode. In development mode, it's going to load this file directly. In production mode, it's going to be smart enough to point to the directory where the minified distributable file is. It's all very cool stuff. If you're interested, come find us in the BuddyPond. Here's the SDK page that you can see here. You can find that in the BuddyPond as well. It's really cool stuff. It's very well written. It's very efficient for both memory and for speed. It's easy to work on. If you need to add a new app or work inside of an app, you usually can do so in a silo, in isolation, without having to worry too much about affecting any of the other apps. All of the core of BuddyPond, such as the windowing system is its own app, right? The taskbar here is its own app. The menu bar at the top is its own app. Every single one of these obviously is its own app. Very cool stuff. Very excited. I'll keep it short today. Like I said, today is day 32 of posting each day until we fundraise $1 million for the BuddyPond. If you're interested, come hop in the pond, hop in the Discord. The links are below. Please like and subscribe. Until next time, hop on the BuddyPond.